The following leatherback sea turtles are found swimming in the Caribbean Sea. The weights of these turtles are 749, 653, 688, and 704 pounds. Add 4 new weights that could be in this group of sea turtles based on their weights. Explain your thinking using words, numbers, or pictures. Take a moment to pause the video and take a few guesses on what you think and your thought process, and we'll come back together and go over the problem. So when I look at these numbers and rounding them to the nearest hundreds, 749 rounds to 700, 653 to 700, they all are rounding to 700. So you could choose any 4 numbers that would round to 700, such as 702, 748, 675, or 651. Using a number line would help us with this. So I've listed the numbers, the 749, 653, 688, and 704 on a number line. And I put an arrow with all the numbers in which we could choose from. So there are many that we could have chosen from. So as long as your numbers were in this group setting, you would be perfectly fine. How many marbles are in the jar? Maybe you might need a little bit more information than that, since they're not real marbles that we can see. In the jar, there are 216 red marbles and 403 blue marbles. Tom says there are about 600 marbles in the jar, but Debbie says there are about 620 marbles in the jar. Who's correct? What do we think? Let's look at Tom's possible solution. It appears that Tom uses the 100 value as his benchmark. So he looked at the the tens category and saw 1 and 0 and rounded that way. So 216 would round to the nearest 200 and 403 would round to 400. So 200 and 400 is 600. So I look at my number line and verify. So either one would work. That 216 is close to about 200 and 403 is also about 400. Let's look at Debbie now. Debbie used the tens as a benchmark for rounding. Rounding 216 to the nearest 10 is 220, and rounding 403 to the nearest 10 is 400. So she gets 220 plus 400, which is about 620. Verifying on the number line, 216 is about 220 and 403 is about 400 when rounding to the nearest 10. This example shows us that numbers can be rounded to more than one place value benchmark. Further, that rounding numbers are useful for estimating amounts, and we can round numbers to add them more easily, and we can round numbers to get a close estimate. Which 2 jars have about the same number of marbles? How are they similar? How are they different? Pause the video, do some checking with some rounding, come back and we'll talk about it. Rounded to the nearest 100 with each of the jars would give us 400, 300, 400, and 200. Rounding to the nearest 10 of each of the jars gives us 390, 320, 370, and 220. So when I look at them, things that they have that are similar is they have a lot of marbles, and 3 of them have more than 300. They're different based on how we round to them. But it appears that the ones that have about the same number of marbles when rounding to the nearest 100 would be the first and the third jars. Homework. There is a rounding worksheet that I provided in the rounding homework Dropbox area. Complete, scan, and upload back into the appropriate Dropbox area to practice more rounding skills, both to the hundreds and the tens category. There are 6 tables in Mrs. Potter's art classroom. There are 4 students sitting at each table. Each student has a box of 10 colored pencils. How many pencils are at each table? How many colored pencils do Mrs. Potter students have all together? We can reason this through base 10 pieces. So I have 4 sets of 10. Each stick represents 1 student, and each student has 10 colored pencils. There are 4 students, each with 10 pencils. 4 groups of 10, so 40 pencils at each table. That answers part A. Now what I'll do is that there are 4 students sitting at each table, each student with 10 pencils, so I've created 6 different groups for each of the different tables. Here we created a visual representation of the 6 tables with 4 students sitting at each table. But I have a lot of 10 sticks here, so we could rearrange them and group them into groups of 10 because I know that 10 groups of 10 gives me one group of 100. So it looks like I can count out 10 of them and I'll end up with 2 groups of 100 with 4 sticks left over. So 2 groups of 100 and 4 groups of 10 for a total of 240 pencils altogether. We can also reason through this using a number line. So each jump is worth 10. We do this 4 times for each student at the table. So 10, 20, 30, 40. 4 jumps of 10 represents 40 pencils. There are 40 pencils at each table. Well, if I know that there are 40 pencils at each table, then I can count by 40s on my number line 6 times or 6 jumps for each table. 40, 80, 120, 160, 200, 240, making 240 colored pencils altogether with the visual aid of a number line. We can also reason through this using a mathematical sentence. Each student has a box of 10 pencils, which is one group of 10. There are 4 students at each table, so there are 4 groups of 10. And that would be 4 times 10, which we know is 40. Moving forward then, since there are 6 tables and 40 pencils at each table, there are 6 tables times 40 pencils at each table in total. This 40 arose as 4 groups of 10 or 4 times 10. So I kind of expanded that 40 into 4 times 10 times 6. So this is written in expanded form here. Using the associative property to help us multiply a little bit easier than 40 times 6, we see that this is the same as regrouping here. 6 times 4, which is 24, times 10, so 240 pencils. We think of this as 24 groups of 10. Let's look at multiplying by a 10 and how it looks when multiplying using the algorithm way that we've learned. So let's look at 9 times 50, for example. We think of this as 9 groups of 50. So here's one group of 50 across the top here, so 10, 20, 30, 40, 50. Then we have 2 groups of 50, giving us, and then now all of a sudden we have 9 groups of 50, so putting them all together. So currently I have 50 times 9. We would know that that would be, we would take 9 times 0 and get 0 in the ones category. Notice we don't have any ones here. They're all a bunch of tens. Well, then if I have a bunch of tens, we need to regroup them into hundreds, correct? So now we have 45 groups of 10 that we need to group into 100. And notice on the column there that then we would take 9 times 5 and get 45. So we have 45 groups of 10. So that's what that comes from when we're using the algorithm to multiply. So now I'm going to group them into groups of 100. So 10 groups of 10 gives me 100, or one group of 100. Notice we can make 4 of these, and then we'll have that bottom 5 left over. So across the top here, we've got 4 groups of 100. On the bottom, we have our leftover of 5 groups of 10 for a total of 450. For your homework, use base 10 pieces to determine if 7 times 40 is the same as 4 times 70. Show your work using either pencil or paper or using some virtual manipulatives. Show your work step by step and add words if needed to make your point clear. Extend each multiplication into expanded form and use the associative property to show equivalent statements. Scan and upload your document to the Multiply by 10 Dropbox. Next week, we're going to work on the geometry and measurement and data of 3rd grade.